So here's the big thing with roots and radicals that we're looking at for this part of it. The big thing for this one is now we're looking at a number that's going to be here inside the square root up in the corner of this one. This n that you have here, that is either the index or sometimes they call that the root. So index or root, that's basically just telling you what number we're looking at. And that kind of ties back into, and the big tie-in for this one is that when we're doing that one, um, when we find our exit buddies, when we're simplifying radicals way back when doing square roots, that's telling you how many of a kind you're looking for. So if the index is 3, you're looking for 3 of a kind. If the index is 4, you're looking for 4 of a kind. So that number is going to tell you how many of a certain number that you're looking at. There's going to be some expression, some number, some variables that's on the inside on this part of it. And anything that's on the inside, that's called the radicand. And the radical, of course, is just the whole expression that's there. Okay, and the way they're going to talk about this one is if they talk about this expression in general, whatever this index root is, they call that an nth root radical. So it could be, if that's a 4, that's a 4th root radical. That's a 5, that's a 5th root radical. 10th root, whatever the number is happens to be there, that's what you want to do. Okay, and the good news for today is what we're doing for this one. That all these expressions that we're going to work with today is that here's kind of the big idea. Here's what you want for this one, because a lot of times people are like, all right, what are we looking for on this thing? That basically, here's what we're going to do for these. You want to simplify. The radicand, what's on the inside, as much as possible. Okay, and again, when we're taking that number and we're breaking it down, we're basically going to rewrite it in factored form. So if that number happens to be 120, like we were doing square roots way back when, we would break it down as 2 times 2 times 3 times 5, or whatever the expression happens to be. So you're going to basically take this expression, break it down as much as possible, and then you're going to write it in factored form. Okay, and again, think flashbacks to the Finding Nemo with the exit buddies. We're going to take this thing, break it down, and we're going to see how much of this thing we can take out of the radical, and then figure out how much is going to be left over on the inside. In a perfect world, if it was, I guess, an ideal situation, so we would say ideally, which sounds kind of funny to say that, but you want the nth root of whatever this number is that's on the inside of the radicand, let's call it b, to the nth power. So in a perfect world, the root here matches the power here, and if that's the case, these two things will cancel each other out. And if those two things will cancel out, your answer is just going to equal b. Okay, and what makes today really easy is that everything we're going to do today, the answer should come out so that we're not going to have anything radical left over for this one. Tomorrow, not so much. We'll have parts left over, parts on the inside. Okay, now there's one little detail we've got to get through today, and this is the part that will be a little less fun, but 95% of everything else will be really easy for this thing. But the one little detail we have with this one that you've got to be careful of is basically this, is that if you get finished and you're working through a problem, you need an absolute value symbol. So this is kind of one little thing you got to look out for. Yeah, you need absolute value around your answer. When the root was even. and your answer is X or B or whatever it is we're doing in this case. So if we're doing B in this case, we'll do B in this part to an odd power. Okay, and again, that's not a huge detail. Think about it this way: if you're doing a driver's test to get your license, what do you do when you get to a stop sign? You stop, and you stop, and it's a good solid stop. You look both ways. You come to a full, complete stop, and you do that. For anybody who's driving, who's already passed your driver's test, what do you do when you get to a stop sign?
You slow down.
Most people in situations, are you going to come to a full, complete stop and look both ways every single time? Exactly. It takes a little bit too long, right? It's a little redundant because once you kind of get the hang of it, it's more of, okay, I'm going to get stop signs. If there's somebody coming, I stop. If there's nobody coming, I'm going to go, all right, I'm just going to ease on through this thing, right? This is that little detail of when we get through this first section, this is us coming to a full, complete stop. We're going to check everything in both directions. We're going to make sure it's all good. After we get past today, we're going to go, we're going to cruise on through. We're not really going to worry about this thing. So it's just that one little detail that if you start off with, if your answer starts with an even root and you have an odd power in your answer, then we're going to put absolute values around it. After we do this today, we're going to go, you know what? We're going to say this is the case and we're not going to worry about it. So this is just that one little detail we've got to get through today. And it's not every time. It's only just a few times in the work that we'll do that this pops up. All the other times we don't worry about it. We just kind of move on. But it's just that, it's just we got to get through today. Once we get through today, we're not going to worry about it the rest of the time. Okay.
So you said if the root is even and then it has an odd power, you're going to put the absolute thing, like the shaking around it?
Yep.
Like the whole problem?
The answer, yes. We'll show you one here in just a minute. So.
Oh, just like you solve it and then you put the things on it.
Okay, so a couple of different problems we're going to look at. Very first example is we're going to list all the roots. And if it says list all the roots, it's a little different situation other than if it just says to simplify. So we'll kind of show you those two things that's here. And we get to start off nice and easy. Square root of 25. What is the square root of 25? It's 5. Now, if it says list all the roots, what other number can you, because again, if you kind of think about this case, if it's square root of 25, okay, that would be a 2 for the index there, right? Second root, that kind of thing. So if we do this one, if we're wanting to kind of have it so we have this power matched up on the inside and the root on the outside, those two things matching up, then technically what we're going to do for this one, again, this is kind of the technical aspect of it, is that this is the square root of 5 squared, right? So the square root and the square would cancel each other out and just give us the 5. Is there another number we can multiply by itself and get 25? Negative 5. Thank you. So when we square root negative 5 squared, because negative times negative is to make it positive, those would cancel. So this is one of those answers because if it's a second root for this one, if it says list all the roots, we're going to put a plus and minus. Now, if the answer and then we'll show on the next one here, some of the other ones we'll do. If the question just said to simplify, then we would just put 5. But if it says list all roots, then we're worried about that plus or minus that we're looking for on this thing. Okay, so let's go fourth root of 16. Okay, so fourth root of 16.
Positive and negative?
Well, yeah, so again, we got to think about something to the fourth power that would equal 16. Yeah, because again, we got fourth root. Now, we know it's not 1, but it'd be 2, right? So we got 2 to the fourth power equals 16. So we know that answer could equal 2. But what happens if we do negative 2 to the fourth power? Also still 16, right? So in that case, we're going to put a plus or minus there. So if it asks you for listing all the roots, if it's an even root, then you've got to use the plus or minus. If it's an odd root, then you won't, because again, if you have an odd number and you multiply negative an odd amount of times, the answer is going to be negative. So if it's an even root, you get to use the plus or minus. If it's an odd root, then basically you just, it's just one answer as you go through this thing. So listing all roots, even X, you got that one. Oh, so here we go. So if it's an odd root, let's give you one of those. So if it's the third root of 8, all right. Okay, that'd be 2 to the third. 2 times 2 is 4. 4 times 2 is 8. So again, third root would cancel. So in that case, that would be 2. Okay.
He's on number 27. He's been doing this for 15 minutes. I don't care. They can
Okay.
do that.
Now, so again, the reason, the difference on this one is if we change that to a negative 8. So if we do negative 2 to the third power, that's negative 2 times negative 2, which would be a positive 4. 4 times negative 2 would then be a negative 8. So really, we'll do the third root of negative 8. That's the third root of negative 2 to the third. So again, 3's cancel. So that would be a negative 2. So if it's an odd root index, then whatever the number is, the answer will have that same sign. If it's even, then we got to do the plus or minus on that part to get us it. Okay. All right. Good to hear that it's simple enough. Okay, so now here's where we're going to go with. So we're going to break away from listing all the roots because some of the homework will ask you to list all. Now we're going to have some of these that we're just going to simplify, which means we're just going to need one answer. Okay, so they ask you to simplify. We only need one answer. We don't need the plus or minus like we did back here when it said list all the roots. That basically we're going to assume that if we do the square root of 25, the answer is just 25. We're not going to put the plus or minus. Now, when it says simplify, it's going to say use absolute value when needed. And that's going back to this thing back here. So if we start with an even root and we have an odd power answer, then we've got to put absolute values around those answers as we go through that. Okay, so simplify again. Now we're just looking for one answer, and we're going to use absolute value if we need it. And again, this is just for today. Tomorrow, when we simplify, we're not going to worry about this at all because now we've got our license. We're good to drive. We're going. We're not going to have to worry about this whole thing. But and again, this will only pop up just every now and again as we go through these. And so we're going to walk you through some just kind of straightforward, easy ones to start with, and then we'll just kind of increase the degree of difficulty as we move along a little bit. All right, it's the fifth root of 0. It'd be okay that the fifth root of 0, you could do 0 to the fifth and still get 0, right?
Yeah.
So those are cancel. So that answer would just be 0. All right, what about the fifth root of 32? So some number to the fifth power is what we're looking for. Okay, that'd be 2 to the fifth power. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. So that's our fifth power there. Again, fifth power, fifth root, those cancel. We just get a 2. All right, it's negative 32. And that should just be negative 2 to the fifth power. So again, 5s will cancel, so the answer would just be a negative 2. All right, let's do the square root of 4. Okay. Okay, and with square root of 4, we know what the square root of 4 is, right? We know it's 2. So we could do that as, the square root of 2 squared so that these would cancel, correct? Okay, but also, couldn't that be negative 2 squared?
Yeah.
Okay, so then we get the squares and the square root cancel, leaves us with negative 2.
So it can be plus or minus.
Yeah, so it could be plus or minus. But again, we only need one answer. So again, this is where we kind of go back to this thing of if it's square root, we start with an even root, this would be 2 to the first power, correct? We kind of go through that one. That basically in this case is we've got to take the absolute value of the answer that it could be. And either way we go for this one, then that's where we're going to come back and this answer is just going to be a 2. So that's that thought process we've got to have is that, yeah, we've got 2 options on this thing. But if we take the absolute value of 2 or negative 2, the answer we still wind up back with is 2 as we're going through that thing. Okay, now let me just kind of give you an idea on this. Let's say we had the 6th root of negative 4 to the 6th power. Okay, okay, that would be negative 4. And really what we wind up doing is that where we've got this 6th root and 6th power, you actually wind up dividing these 2 things together. So really this is like the 6th power. We're going to divide it by the 6th root. So that gets us to the first power. And that's kind of what we're moving to before we're going through on this thing. So this is really negative 2 to the first power. So technically on this one is that since this would be to the first power, we're supposed to put absolute values around the answer. So that answer would actually just be 4. Because again, if we do negative 4 to the 6th power, that would be the same answer as if we did 4 to the 6th power. So we can take either one of those 2 numbers and get that exact same number. So just so we can have one answer, we're going to do absolute value of that one. So we're just going to say that the answer is 4 there. All right. Now, let's take us back a little bit. What happens if it's the square root of negative 49? I think back to before we did now again, we're not doing imaginary numbers. Everything needs to be real answers on this one. So think back to before we did all the imaginary numbers. What was our answer if we did the square root of negative 49? Anybody remember? Seeing somebody shaking the head over there. Scott saying, yeah, you cannot do that, right? That's one where you get no solution. So in this case, yeah, that will just give you a no solution. And again, we could do it with imaginary numbers and make it be the numbers, but we're not doing anything imaginary. Everything has to be a real number answer. So in that case, if we happen to do that and it turns out that way, we cannot, because again, if you do negative 7 squared, that's going to make it a positive 49. If you do 7 squared, it's still positive 49. So there's no way we can take this number and have something to the 2nd power and it be negative if it's not imaginary. Now, if it's imaginary, we got it, but we're looking for real number answers. Okay, if they happen to throw a fraction at you, it's the square root of 36 over 121. You can do it separately. So what's the square root of 36? 6. What's the square root of 121? 11. So now we just make it 6 over 11. And that would be an answer where you would not put it in decimal form. It should say write the answer as a fraction in simplest form. All right. May also get a decimal number. Square root of 0.09. If it was 9, we know it would be 3 times 3. But since it's 0.09, honestly, this is one of those where you can just use your calculator and check it. If you check that one, that's going to be 0.3 for your answer.
Why'd you skip H?
Oh, sorry. Let's make that an H. There we go. That's H. Wasn't paying attention. Okay, so everybody okay with the simplifying? I mean, pretty straightforward. Again, a couple of little things that we're kind of worried about. That's to me is the tricky one. That if you start with -4, that the answer is +4 at the end. But again, they're assuming that if you do -4 to the 6th power, you get that number and it'll be a positive number. So then we're doing the square root, or in this case, 6 root of a positive number, so the answer should just be positive. So basically, the only way the answer is going to be negative, if it says to simplify, is if it's an odd root and it's a negative. If it's an even root and we do it to the 6th power, it's going to make it positive. So the answer will eventually turn out to be positive as we go through that. Okay. All right, now here's the part where it almost gets even easier in some of these to me. Because the numbers are okay, but the variables actually get easier to me. Okay, so we're going to simplify variables. Really, really easy. We're going to divide the powers. Of the radicand. Again, radicand is what's on the inside of each variable by the index or by the root, whichever way you want to call it there. So basically, you're going to take the numbers on the inside and you're going to divide it by the exponent or the index or the root that's on the outside. And you're going to look at this and you go, man, this is like really easy. Yeah, and it is. It's really straightforward today. Okay, so let's say we're doing the third root of x to the 12th and y to the 18th. Okay, here's how easy it is. We're going to take 12. We're going to divide it by 3. We're going to take y. We're going to take the 18th and divide it by 3. Twelve divided by 3 is 4. 18 divided by 3 is 6. And boom, and there's your answer. Just that easy. So again, to me, the variables are even easier than the numbers because I don't really have to think through it. I just have to just divide the two numbers, and that's it. That's all I have to do.
Why have we waited so long to get this?
All right, square root of x to the 6th. We know the index is 2. So we're going to take 6 and divide it by 2. Easy enough, we get x to the 3rd. Now, here's where and this is where it really makes sense, because back here, when we're putting absolute values, you may have been looking at that going, well, that doesn't really make a lot of sense because, you know, what it is. This is where it's going to make a little bit more sense. Here's where we need this thing. You need absolute values around your answer. When you start with an even index or an even root, and your answer is an odd power. We've got an even index. We've got an odd power. So we're going to put absolute values around that answer. So we're basically trying to make sure that all the answers we get are positive. If we don't have the absolute values on this one, we plug in a negative number, we could get a negative answer. So we're trying to make it so that every answer we have will be positive, which will make things easier. All right, so let's do the square root of 81x to the 4th power. All right, so if they give you a number and they give you variables, you can basically break it up into two different parts. We're going to do the square root of 81, and we're going to do the square root of x to the 4th. Okay, square root of 81, we know that's 9. If we did the absolute value of 9, it's still 9, so we don't really have to worry about that one. We've got absolute value of, square root of x to the 4th, so we take 4 divided by 2, that's going to make it x squared. Again, even index, we don't need it. The only time you need the absolute value is, again, if you start with an even index and you get an odd answer, we're going to put absolute value around it because basically right now we're trying to make it so the answers are positive, so it's easy to work with. if it's a situation where it could be positive or negative, so we're trying to make it so that we don't have that, well, it could be positive, it could be negative kind of thing. We're just trying to take that one out so that there's not any question as to what it's going to be. All right, so let's do this. Let's do the fifth root of 32. Let's do x to the 10th and y to the 40th. Okay, so it's the fifth root of 32. It's the fifth root of x to the 10th, and it's the fifth root of y to the 40th. Okay, and again, we did 32 earlier. So we did the fifth root of 32 earlier. That number was just 2. For this one, we're going to do 10 divided by 5, which is also 2. And we're going to do 40 divided by 5. So that would be 8. Okay, and again, no absolute value symbol is needed because we started off with an odd root or an odd index. So if the answer happens to be odd, that's okay. But again, if it's x squared and y to the 8th, no matter what you plug in here, this answer will always be positive as we go through that thing. Problem with 8. Fourth root of x to the 12th and then y to the 16th. Okay, so for x, it's 12 divided by 4. For the y, it's 16 divided by 4. Easy enough. That's x to the 3rd and y to the 4th. Okay, but we started off with x to the 4th, right? We got an even root. We've got a odd index, odd power answer. So just for the x, it's going to get absolute values. The y is okay because if we do something to the 4th power, this answer will always be positive. This is the only one that possibly, if you plug in a negative number, you're going to get a negative answer. And we're saying is, okay, in this case, we need to make sure that any of the numbers we pull out, that the answer could be positive. So we put absolute values around it just so on the safe side that we need that answer to be positive as we go through that.